The next presenter with the code of SEE-10 is Ms. Dede Zariatin from University of Pancasila. So Ms. Dede will present her research with the title of The Analysis of Gravitational Vortex Turbine Performance. So, Ms. Dede, please.
Thank you very much. Good afternoon, session chair, Ms. Sylvia, uh, speakers and participants of ICONETSI 2020. Thank you very much for the opportunity given to us in this respectful event. My name is Dede Zariatin, and I'm here to present our research article entitled of Analysis of Gravitational Water Vortex Turbine Performance. Okay. Hydropower is one of the renewable energy sources provided by nature. Generally, hydropower uses water sources with specific height, like a natural waterfall or even make a dam. Sometimes it is challenging to find a waterfall or high water source, and it's costly to build the infrastructure. However, some technologies make it possible to build a power plant using a low-head water source, such as a cross-flow turbine, horizontal spiral turbine, turbo, Kaplan, and gravitational vortex power plant. A gravitational vortex power plant uses a water vortex or water wheel flow to rotate the turbine and generate power. The advantages of gravitational vortex power plants are that it can be operating in the ultra-low hydraulic head, low cost, environmentally friendly, especially for fish, water plants, and microorganisms. The water vortex principle was introduced by Victor Schauberger, and then it is developed by other researchers. One of the water vortex turbine designed by Davis S. Sanders was patented back in 1978. As shown here, that the runner placed on the upper basin. Meanwhile, the other figure shows a recent patent by Slagmulders in 2017. Slagmulders put the runner in the bottom basin. Another experiment facilities was developed by Nishi. With this facility, they deliver several articles about its performance, hydraulic loss, and flow behavior. And another test experiment facilities was developed by Salim to investigate the effect of height, runner position, submerge of blades, and other parameters. This research aimed to develop a laboratory-scale single-stage gravitational vortex power plant as a testing facility for further research. The developed vortex power plant's performance was examined with 3 different blade material to find out the effect of blade material on power generated and the hydraulic efficiency. The research was begun by designing and manufacturing the gravitational vortex power plants. The vortex basin consists of 2 circular pools. The first pool is where the blades is installed. The other pool is where the water pumps from the tank. And then it flows from the second pools to the first pools due to the gravitational height differences of 0.4 meter. The basin is made of stainless steel 304 with diameter of 560 millimeter for each pool. The The next step was testing the developed gravitational vortex power plant. There were 3 runners tested in the experiments as shown here. It is made from 3 different material, which is stainless steel, 304, aluminum alloy 5057, polyvinyl chloride, or PVC. Okay. Sorry, I have to go back to the previous slide. Okay. It has 4 straight blades with a thickness of 2 millimeter, and each runner overall weight, including its shaft, is 5.5 kilogram, 3 kilogram, and 1.9 kilogram. Okay. The figure illustrates the water flow in the testing. The tank here stores the water. It is pumped by a water jet pump through a pipe and delivers to the vortex basin. The water hits the runner and then rotates the generator shaft, and a tachometer is used to measure the rotational speed. Meanwhile, a voltage and current measurement was performed by a dual module DSN-VC 288. Sorry, there is a chat. Should I read the chat first?
Which one?
I see.
Question?
Oh, yeah. I don't know. It's pumping up on my screen.
Okay. Maybe
Okay.
I think it's you can read it after the presentation.
Okay. So I finished my presentation right now.
Yeah.
Okay, thank you. Sorry, because it keep on pumping on my screen. Thank you. Sorry. And then here hit the runner, and then the electric power was measured by a dual module DSN-VC 288. It is put inside the electric panel equipped by 2 LED lamps here, and a stopwatch and measuring bucket were used to measure the water flow manually. A valve is placed here on the pipe. It is regulate the water flow. 5 valve opening of 30, 45, 60, 75, and 90 degrees, which is the fully open, were assigned. Theoretically, hydraulic generated from a hydropower plant can be calculated by using this equation, where the rho is water density with the value of 997 kilogram per meter cubic, and G is the gravitational with the value of 9.81 meter per second square. Q is the flow rate with the units of meter cubic per second, and H is the height differences of head in vortex power plant with the value of 0.4 meter. In the hydraulic power calculation, the flow rate unit converted to a meter cubic per second. However, to maintain the experiment data consistency, the graph is written in liter per units. The experiment was performed in the laboratory with a room temperature of 29 degrees Celsius and humidity of 77%. 3 independent variables of shaft rotational speed, electric current, and voltage were recorded. The electric power is the multiplication of electric current and voltage. This figure shows that the rotational speed of the shaft generator produced by each flow rate as the valve opened gradually. It can be seen that the runner made of PVC has a deficient rotational speed compared to those from aluminum alloy and stainless steel, especially in low flow rate when the valve open in 30, 45 and 60 degree. When it's open 90 degree, the maximum rotational speed was achieved. This figure shows the power generated by each runner. It shows that the runner made from stainless steel 3 or 4 generated higher power than aluminum alloy and PVC, which is 3.9, 3.4, and 3.3 respectively. The maximum efficiency was achieved by stainless steel with the percentage up to 31.8% compared to its hydraulic power. The efficiency of the developed Vortex turbine could be improved, for example, by modifying the runner shape and dimension. Both figures, 6 and these figures, both of them, uh, this figure shows that there is a correlation pattern between the blade runner material to produce rotational speed and electric power. Each blade runner has a different weight because it has a different density. This figure shows that the heavier the runner, the higher the power produced. The correlation of runner weight to rotational speed is statistically significant. It can be proved by a p-value of 0.038, which is less than 0.5, and Pearson value of 0.998. The equation here shows the regression equation of weight effects to rotational speed for this experiment. And then here, this is the regression equation for affected to the power generated. It is also shown that this is statistically significant with a p-value of 0.036 and Pearson value of 0.998. So the conclusion of this research is, in this research, we are develop a laboratory scale gravitational vortex power plant and 3 different runners made of rust-resistant material, stainless steel, aluminum or alloy, and PVC were tested and generated electric power of 3.9 watt, 3.4, and 3.3 watt, and it can run a 3-watt LED lamp. The hydraulic power efficiency is up to 31.8%. The blade material with different weights significantly affects the generator's shaft rotational speed and the electrical power generated. It can be concluded that material with higher density will be heavier and will generate more electrical energy. Our conclusion concluded this presentation. Thank you very much.
Okay, thank you, Dede, for the wonderful presentation. So now I will open the Q&A session. For all the participants, you can write the question in the chat box. If you have a question related with the Dede's presentation. Okay. Okay, Bu Dede, maybe for the first question is from me. For the research, you three types of the material were used in the development of the gravitational vortex of the wind turbine. So why you choose the three material?
The reason I choose the material?
Yeah.
Okay, first of all, those 3 material is water resistant. So it cannot, it's not corrosive, and it is safe to be put in the water for a long time. That's why we use those resistance material instead of maybe cast iron or something like that. That's the reason.
Okay, now we have the first question from Bu Evita.
Okay.
The question is, it looks like that in your experiments you do not measure yet the half. Do you plan to do it?
As I mentioned before, that this gravitational vortex power plant, this kind of micro hydropower that use a low head, and I mentioned that in the presentation that the head of these facilities is 0.4 meter. 0.4 meter. However, this is the advantages of gravitational power plant that it is operating in a low head. So it can be placed anywhere as long as there is a waterfall such as a river with a strong flow rate. So it is very promising in Indonesia.
Okay, thank you, Bu Dede. For the next question is from Pak Samuel Kusumo Cahyo. The question is, what about the mechanical properties of the polyvinyl chloride in comparison to steel?
Okay, of course, it is very different. If we talk about the mechanical properties, first of all, about the strength of material. For PVC had less strength of material compared to steel. And the most significant that we are investigating in this research is its density, the weight behavior of each material. So in this experiment, we try to compare those two or three with aluminum alloy material properties to generate power. As we know that PVC is very cheap, less economical stainless steel. But however, it is that the stainless steel give more energy power than the PVC. I think that's my answer.
Okay, thank you. And the third question is from Pak Eka. Is there a minimum speed of the water to use the vortex, the gravitational vortex turbine?
Okay, thank you, Pak Eka, my colleague from SGU. Okay, there is no minimum power, minimum speed of water. Even the slowest flow rate of water, as long as it can rotate the runner, that it can be generate power. As long as it can rotate the runner and then rotate the generator shaft, then it can generate power.
Okay, thank you, Bu Dede. Thank you. I think the
Welcome.
time is up. So thank you so much, Bu Dede, for the
You're
presentation
welcome.
and also the knowledge
You're
you share with
welcome.
us.
Okay, thank you.